Now, database terminology show understanding and the use of terminologies associated with relational database model, including entity, table, record, field, tuple, attribute, primary key, candidate key, secondary key, foreign keys, relationships, one-to-many, one-to-one, and many-to-one, and referential integrity alongside indexing. So let's review those. Now, relational database model terminologies. In order to rigorously define the structure of a relational database, we need to be able to understand and use terminologies associated with the database. Now, a relational database data structure can look similar to a file-based structure, as it also consists of records and fields. A table is a group of similar data in a database with rows for each instance of entity and columns for the attributes. So these are basically records, columns are fields. A record is a row in a table in a database. A field is a column in a table in a database. That is very simple. So record and field. So this is complete table. For example, a database of students in a school could contain the table student with first name, second name, date of birth, and let's say ID. So this is sort of database table. Now, data is independent of the programs processing it. That was the beauty of the database, that data is independent of the programs. Programs, when they like to use, if they have access, they can use the same database. The term record and field are also used in file processing, so there is more rigorous terminologies used specifically for relational databases. Files of the data are replaced by tables, with each row of the table representing a record. Record is also called tuple. A tuple, sometimes called a logical record or an occurrence of the entity. So a record is basically showing an entity, individual entity. Each column of the table is an attribute. That can also be referred to as a field. An entity is anything that can have data stored above it, such as a person, a place, event, or an object. An attribute is an individual data item stored An attribute is an individual data item stored for an entity. To use the same example as this, for a student, attributes could include first name, second name, date of birth, and class. As I just said, a table is a group of similar data in a database with rows for each instance of the entity, means a student is entity over here, and columns for each attribute of those. A tuple is one instance of the entity which represents by a row, which is a record. Data is shared between applications using the database in order to ensure the consistency of data updating in controlled or automatic way so that any copies of the data items are changed to a new value. Also, in order to reduce the number of copies of the data items to a minimum. A relational database uses pointers between tables, means relationship. These pointers are keys that provide relationship between the tables. There are several types of keys, but for you there are three. Number one, the candidate key. Candidate key, the word key is for the fields which are actually having some special values attached to those. For example, a candidate key is an attribute or the smallest set of attributes in the table where no tuple has the same value. A primary key is a unique identifier for a table. It is a special case of a candidate key. A secondary key is a candidate key that is an alternative to the primary key. So let's say there are three candidates which are standing and competing in an election. The one that is chosen is primary key. The other two are then secondary keys. And before the election result announced, they were all candidate keys. But they all three has different data in their column for every record. That is why they can be selected as the primary key individually. All right, that is how it works. So candidate key, primary key, and secondary key. Secondary or alternative keys. So let me revise. A candidate key is an attribute or smallest set of attributes in a table where no record has the same value. A primary key is a unique field for a table. It is a special case of a candidate key. A secondary key is a candidate key that is an alternative to the primary key. And then comes the foreign key. A foreign key is a field in one table that refers to the primary key in another table. This foreign key and primary key relationship is basically the one that maintains the whole sanity of the database, relationships between the tables. And remember, in one relational database management system, if there is one table, that is fine. Otherwise, no table can stay in the database if it has no relationship with at least one another table. For example, a database of, let's say, chemical um elements in chemistry. So the fields are symbol, then name, and then let's say atomic weight. Let's say there are three records. So H for hydrogen, that is atomic weight. L and then I is for lithium, that is 6.94, and then Na, that is for sodium, and 22.990. So these symbols are primary key, and these all keys are candidates key. Any one of them can become a primary key. So these all elements are candidates, but we have chosen this one, so this becomes primary key, and name and atomic weights then become secondary keys. This is primary key, and they all are candidate keys. Okay. Most tables in general world have only one candidate key, which is used as the primary key as well. Okay, so now it is done. Let's discuss relationships. A relationship is formed when one table in a database has a foreign key that refers to the primary key in another table in the database. In order to ensure referential integrity, the database must not contain any value of a foreign key that are not matched with the corresponding primary key. So let's say this is a table for students. Every student has an ID and then class and then several other, and there is then a class. Class, number, teacher, whatever. So in a class, there are many students. So this primary key is being referred over here as the foreign key. So it is a must that the values over here, when they are used in strict coherence of the keys, or the values over here. So all the items in the class over here, if they are used in the foreign key, they must match one of the values. So foreign key should have the values which are actually in the class table, but foreign key can be left blank. So if a student is entered the school but not yet and taken an admission in the school but not yet assigned to a class, so that class field can be left empty. But if there would be any value in it, that value must correspond to the value in the class. So most databases are including more than one table. For example, this a school database could contain a table student and another table class that contains the class ID, the teacher name, the location of the room and all. Only values for class ID that are stored in the class table can be used as the foreign key in the student table. All right. So now relationships can take several forms. So relationship forms. Number one, that is one-to-one. Number two, that is one-to-many. Number three, many-to-one. And number four is many-to-many. Now, these are the different forms of relationship. The relationship between student and class is many to one, because this is many side or this is one side. And the relationship between the class and a student, it is one to many. All right. As one value of the attribute class ID may appear many times in the student table, but only once in the class table. In order to spend up searching for the data, an index can be used. So now index. This is a data structure built from one or more columns in the database table. So over the hard disk, in order to search for the data fast, all of the hard disk data addresses are indexed and they are available in the memory. So as soon as you try to search, instead of searching physically over the hard disk, that might take a lot of time. Rather, the index of the addresses over the hard disk is used and it is calculated or seen or managed in the memory, and then system goes directly and access from the disk. So in order to speed up searching for the data, an index can be used. This is a data structure built from one or more columns. Whatever the number of columns that the primary key has, sometimes we don't have a primary key that can be managed using one of the fields, so we take several fields. So if we are taking several fields, then that primary key is called composite or compound key. So in that way, we would have more than one columns used for the primary key. So index can be built, it's a separate data structure though. It can be built over the primary key, which is single column or composite. This is a data structure built from one or more columns in the database table. The student table should be indexed on let's say the student ID maybe, and the class must be over the class ID. And then we have, let's see what is further in the syllabus. So we have discussed entity, table, record, field, tuple, attribute, primary key, candidate key, secondary key, foreign key, relationships, which are one-to-many, one-to-one, many-to-many, and referential integrity and indexing. So that's about this topic.